Hi everyone, here's Simone from Unwrapped Studio and welcome into this new Touch Designer tutorial. Today we will speak about portable scene in Touch Designer and how to pack everything we need in order to have an animated scene and interact with it. In order to follow along with the tutorial, I provide a shared folder in which we have two toxes that we will use in this tutorial, an FBX that we will use in this tutorial, and the Blender file I download from this website. The license of this 3D object is for personal use only. So I'm teaching for free, so I hope nobody gets offense. So please download the folder and drag the Explorer in your networks. Once you do that, you should have this result, as mine. We can interact with the camera due to the viewport, and we have some button in order to go and interpolate within state of a given animation. Let's go inside and see what is happening. This is the wall network. It's not so complicated, and I will start by explaining the locked operator. With SOP we can contain 3D data, and if I lock a SOP and then I save my project, I can embed the 3D data in the Touch Designer project, so I can export them. Not only with the toy, but if I then create a tox as I did, and I have a locked null inside of the component I'm exporting, I will then save those data as well. The animation is baked in a 3D texture. More about it later. And I'm reading this 3D texture with a timer that is only a placeholder for a scrub. And with this fraction I can scrub this amount of frame. So it's pretty handy to configure. And since I'm using the fraction in the cue point of the timer in order to read the 3D texture, I can relay to an LFO a shifted sign, okay, and in order to have a 0,1 constant that is moving. I can use this movement, that is a loop, in order to loop certain part of this 0,1 range. The part are defined as table that are switched and then passed with Python references to the operator needed. The interpolation is given by a lag. That is not so useful, but it does its job. I can control it with a radio button widget that you can find in the palette. A grid is making the floor, and I'm using where is it? Yeah, I'm using a fog, a linear fog. So this gives a bit of more like depth in our scene, I guess. Okay, let's take a look of where we are doing the magic. So how we are gonna like place those points stored in a 3D texture and move this guy. So let's think about that. This guy is our starting position. Okay, so let's put it stop. So this guy is our starting position, and this is containing all the vertices that are in this animation. Okay, so the two things match, but this is static and this is moving. Okay, this is the code. I just didn't change so much about what is given from a default fong. Beside adding zoom a bit more, the index of all point. I already described told why in my previous tutorial, and the width of the 3D texture, and since it's a 3D texture, a 3D sampler is needed in order to sample the cube. You can imagine a 3D texture as a cube and a 2D texture as a square, or a rectangle and a parallelepipedus, I don't know how you call it. Uniform float is in order to scrub the animation, so I call it scrub. Okay, so I can then pass a float and interpolate between all the layers of this beautiful cube that is containing our animation. So I can go through this cube. So line 27 is written my pose, so is how I call my new animation, so my position, because I want to then pass it. And I'm using texel fetch. Texel fetch is a function that takes each pixel of a texture and read it accurately. So each one can read a sampler, okay, a texture 3D in this case, so I can read a sampler, I can pass it here. And the last parameter is the level of detail. And in here the sampling point, that is actually, this was described why in my last tutorial. So with this one I'm taking the index and splitting it in how many parts needed in order to fix this width. Okay, so imagine you have something long 10, you want to divide it in piece long 2. How many pieces you'll have? Okay, this is doing this operation. This is just returning the same number each time. This is why you create the sampler. How you create a square sampler with a given index and a width. And then the last part of our sampling point is the scrub uniform I define in order to read the cube. For normals, we will now make a little draw. Okay, I was thinking, and I really hope that is correct, but I mean it's giving nice result visually, so I really hope it's correct. We had the geometry. Okay, the geometry is giving us P, that are the point position that we can use in the vertex shader, in vertex stage. Then we give N, that are the normal to the P, related to this position. And then, pardon, I need to quit my phone, everybody wants to speak with me today. Nice. And then we have a texture that is defining a version of P. So it's the same things of P, but is the 3D texture that is containing all the animated P. Okay, so my idea is that I can then think that this is my start position and this is all my end position. So I can actually take the difference of these two, okay, and define how much I move from this one in order to arrive here. So I can create a difference that will be a vec3, and my difference, since I then need to work in normal space that is like normalized, I cannot have like negative numbers. And also because if the difference is 3, I don't care, it's 3. So I need something that doesn't care about the sign, and I can take by asking the absolute value of what? P minus the version of P that move given by the texture, given by the frame that I'm reading in the 3D texture actually. So with this expression here, we got how much I move from P in order to resemble the position given by the texture. Wow, okay. We can now think that if this match this, so if N stay in P, okay, I can say that N plus the difference, so how much I move, will stay to TP, okay. So with this concept, I can say this is a proportion, okay. If these two are proportional to each other, if I then offset the normal based on the difference of the position of these two, then these things match this. So those are my new normals, and it's pretty cool because with two subtraction and an absolute, I have normal that update automatically, and it's pretty cool. How to do it? we will actually write it later together. Okay, nice. So this is the scene. I really hope I did not scare you too much. Okay, then let's open the gift I made you. So you should have the recording. So you go in your beautiful folder, you download. Now we use this one, recording, and you drop it in your network. Okay. So the next stage will be really CPU intense. And so my FPS will drop, yours as well. No worries, we are here to fight this together. Okay, so you open it, of course we give an error because it's not super basic tutorial. So this is an FBX component, this is the things I made for you, for us, for everybody, and so it's not super basic tutorial, so but we can just re-import this guy and then breaks. So I need to point it and I should be happy. Yeah, okay, nice. So you should point this guy to the FBX we download. So you already see my FPS are dramatically crashing, and you should point it here. Inside here there are a lot of files that are the armature binding and one FBX. You point it to that FBX, okay, and you have now at the end of this beautiful chops chain this guy, okay, and you should be able to see what I'm seeing and scrubbing the animation. Okay, so now I will define a shorter, so I will initialize everything actually, and I will define a shorter piece of the animation. Okay, so I don't know how many frames are they, so 400 frames, okay, it's fine. So I will initialize this, and I now decide that I want this part of the full animation that is inside of the FBX. Okay, so I will put it here, says stop it, okay, and go a little bit inside and explore the FBX. So we go inside Word again, Xform, and then we have all the pieces. So this is way too much to handle. Okay, to me, not really, but for this example, it's too much. So what I'm selecting with the select shop, it's this piece here and this piece here. So both together. Okay. And we have the animation. Okay. That can be in multiple ways. And this analysis you see here, this analysis, that is this file here, that has a placeholder in the component, in the UI of the component down here, is taken from the FBX animation, but when the FBX animation is in output full range, then became a huge chop. You copy it, you lock it, so understand this trick, and you put it here. So if you want to reuse it, and then here I'm doing an analysis in order to analyze the peaks, and so you can at least see what is happening and try to find loop or have a visual understanding of your animation. Okay, so let's go back in the state we need. Specify index. Okay, for all my Patreon, I will make a series how to use this one in a more efficient way, how to use it with ABC file, and so yeah, there will be more about this pipeline in my Patreon page, so stay tuned. And okay, now we want to create here a 3D texture with this animation. Okay, so we have now to go like chirurgy mode with Touch Designer. So now I will pause Touch Designer, go to the first frame here, and set his range limit to once. I will now go and see what are the data of my animation. Okay, the data of my animation, I need to understand the framing loop, so how much this red thing is long in frame. I have it already calculated with this expression. Okay, and you can use this number and put it here. 424, and then here as well 424. Okay, then if I press once and I press yeah, I press play, but this is stopped, so wait a second, initialize. Okay, so if I now press play, okay, this guy is moving, our FPS is crashing, of course, no problem, it's normal. And then when I arrive to the end, Touch Designer should stop. And this is really useful because we can then deal and lock our 3D texture that will contain the animation. So I want to be sure that the configuration I'm using will actually stop after all those frames. Yes, you see, timeline and touch designer stopped when I arrived to this frame. Pretty cool. Okay, let's go back to the first frame and everything goes as suppose. This will be initialized, okay? And I need to remember to give this a play. Okay, now chirurgy mode. We are touch designer is stopped. We are in once and we are at the frame start, but we can still interact with the network. So if I press tab, I want to create a 3D texture. Okay, so how many frames we need to store? We know it. It's written here. So it's like 4 to 4. Okay, then I connect this guy here, and I want to see the 3D texture. As you see, we create our first frame in our 3D texture. Pretty cool. Okay, so we can go now and see the animation while it's recording. If I set up everything correctly and you did as I did, I really hope that when I press play, now we start recording, and when the animation stopped, we can lock the 3D texture. Are you ready? I hope so. Okay. Here we are compiling. Important things, pardon. Your project should not be real time unless you have a really freaking powerful computer. Leave it out so you store better data. You don't skip frame and it's better. Okay. Ta-da! We now bake this red part of the animation inside here and we can lock it. Okay. Then we can save the project, and this will take a while because you just store a lot of data. Give it the time the touch designer need, and no worries. Even if it take long, we'll save it. 3, 2, 1, save it. Be patient. Be patient, will work. Okay, ta-da! So we now save this data here inside of our project of touch design. So next time you open it, will take a while, but you automatically allocate these things in your GPU automatically. So we are now allocating half gigabyte GPU. Oh no, so this one is not even 100 megabyte. Not even 100 megabyte. It's super cool. Okay, so we can now uncook the FBX by pressing the X, and also this guy we don't need it. Okay, we now only need, we can even detach this. Okay, we just need this. Let's go back in the loop of touch designer. Voila, and we have everything we need. So let's now also think of what I explained before. We need a starting point of P. So we take a null, we plug this guy here, any point it's fine. So I lock it here and I disconnect. So okay, this is my object, and this is my animation, right? And now I want what? I want to put this guy in a geometry. It is our bridge with our GPU, okay? I already make a render, why not? And then I make a camera. And then I make a Fong. Okay. And I have this guy. I now point the camera in somewhere in space. Where are you? Why on earth I'm there? I should be here. Pardon. Because we are also rendering this guy. Okay, so be sure you take out the render flag. If not, if now we press H, we have only one model rendering. So if this happened to you, it's because we have in the same network two components that have render capability, and you can disable the render capability of an FBX by clicking these two buttons here. This is to go in the render top, and this is to don't be displayed in the geometry viewer. Okay, with all that said, now we have a black thing that is not good. We want to have some light. Nice. And we want to actually point the light like this. And yeah, fancy. We go a bit like that. Okay. And is nice because now we configure also the shadow as good as we can. We want to create a grid. Okay. Want to put the grid in a geometry. So, okay, now the grid is there. We want to put it in Z, in this direction, ZX. So it's a flat ground, and we start to make it big. Okay, now it's big enough, and we move it until it touches the feet of our geometry. So kind of like this, not too much. Yeah, something like this is nice. So a bit more. Yeah, I think like this is nice. Let's go in the light page. You enable shadow, you go in soft shadow, and it's already kind of looking good because of the position of the light. Okay, so the light see all the point where the guy is and where you should cast the shadow. Okay, this is the trick. So you should put in the view frustum, is called, in the view of our in the cone view of our light. You should also see the shadow caster and where the shadow should arrive. Okay, I can make the things a bit bigger, maybe even. Yeah, like this is nice. So now we have a kind of nice soft shadow out of the box. Let's leave it as it is. It's fair enough. And yeah, let's now make a bit of space because we need to work and compile this Fong. Let's add just a noise as texture from our Fong color map. Assign it, nice. Let's make a colored guy. I want really punchy color. Another palette like this, or I don't know, like this is like kind of flower robot. And now I want to output the shader for this guy. I can then include the geometry shader, or not, actually not. And then we have the same guy but in code, so we can apply. And why are you black, bro? Let's maybe output the shader now. That's pretty strange. Why didn't take a color? Okay, you need to include the lightning, and then we have the same material. Okay, nice. Was a bit tricky. So now we have the same material translated with this horrible texture, and we need now to in the sampler to compile the material as we need. So I take this 3D texture and make it in the sampler slot, and I call this guy as anim because it's a sampler that it is representing our animation. And I know I will need some more stuff like the width of the 3D texture. So I can refer to the operator anim and then pass the ask for the attribute, so width. Yeah, so with this expression I go here and I ask for the 3D text for the width of the 3D texture, not the depth but the width. Then I want what else? I need another one for that they call scrub, because this will scrub the 3D texture. So this number here, it's a float. What else? I need then a point shop, because I need also the index. If you follow my previous tutorial, you already know where I'm going. Since I need to sample a square texture, I need this guy, this integer that they call index, and this is me dot input point dot width dot index, because I'm asking for the index. Okay, so we are now adding a custom attribute called index, and I think we have everything we need in order to read the animation baked in this 3D texture. Voila! So before the void we can declare stuff we need. So I call my data, and my data are so we can see my data are a uniform that is actually the 3D texture, so it's a sampler 3D, and that is called as anim in the math object. What else? I need a uniform called that is an integer, that is the width. Then from shop word, so I need an in. From shop word I want to read an integer that is called index, and yeah, then I want to read the 3D texture with a float that is called scrub. Okay, and I represent my data that I compile the object with this statement here. So you can use those parameters inside the shader. Really good, really happy. Okay, then I need to find out where we are dealing with geometry. So is this. When TD deform is called on P, you are dealing with geometry, with points that in this stage are vertices. So we create a vector that we call my pose, and my pose is a texel fetch of what? Of the sampler I provide, and yeah, the third argument is 0 because I want to have the level of definition is the maximum I can have. And inside here we need the sampling point, that is an IVEC3 this time. Last tutorial we were dealing with 2D texture, now we have 3D texture, so we need a sampling point made from a vector that is made of integer in 3 dimensions. And we can define this as the index modulo the width, and the index divided the width, and the last part of this sampling point, this 3D, so has 3 data in it, is scrub. Okay, so imagine you have a square and you have a cube, and you pass this square and you read the cube. This is what we're doing here. Nice. Okay. Now, speaking about normals. Okay, how to update normals. I really hope this is mathematically correct, but it's giving really good results. So we will go with these things in our mind, with a relationship. Okay, so p stay to n as the version of p that we have from our texture, from our 3D texture, so is an animated version of p. It's the same number of points of p, but in another position. That makes sense. Stay, okay, to n plus how much I move from the static point I can have from the geometry and this animated point that is given from the texture, that I call this difference. Okay, so with this relationship in our mind, that is a proportion, okay, we can calculate recalculate the normal. This should be a plus sign anyway. Okay, let's make a square. This square is our geocomp. Okay, from our geocomp we have p, okay, and we have n that are the normal for this given p. Okay, and then we have our texture position. Okay, so I will now calculate the difference of how much I move from the given static point from the geo and the animated texture. So I can just do p minus tp, okay, but this will give a negative result that for the space where I need to go and work is not good, because I'm in a normalized space, because I'm working with I have a normals. The normals are 0, 1 because they are normalized. So in this space negative is really bad, and so I will call an absolute. So I will have the absolute difference of how much I move from here in order to arrive here. Okay, so I can actually, since I have how much I move, this how much I move can be used in another place. So and I will use it to offset the normals. So I add this difference, that is the offset how much I move, to the normals. So I move the normal according to our text position, and I use this. I don't calculate it. I use it and I add how much I move. So I automatically update the normal based on the animation. Ta-ta-da-da. Okay, so let's do it. We need to go and find where we are dealing with normals. That is here, workspace normalized 3D deform n. So we create this difference, that is the vector difference, that is equal to the absolute of p minus my pose, and I already know I need to, this is given a vec4, so go back and squeeze out the vector you need to, line 39 for me, and then you go back in the normals, so you can use p, that is capital, and p is a vec3, and then you can do this simple subtraction and add the offset to the normals plus diff. Okay, we have an error. Why? I may forgot semicolon. Yeah, here. Nice. Okay, so if you compile everything correctly, I will zoom a bit out so you can read and copy. This is the line this is the line that is fetching the data from the 3D texture. Okay, we are assigning it. No, we are not assigning it, so let's assigning it, my pos here. Okay, so we're calculating the position from the texture, sending the position to the 3D deform, updating the normal with the difference of from the given point and animated point. And we can now use a scrub. Do I type here scrub? Yes. So now, if I'm not like too crazy, this guy is moving. As you can see, it's alive. And we are running 60 frames per second. We can even make this guy sound reactive, you see? We can move it. Easy. Okay? So, the tutorial it's over. We arrived to a point where we have a nice render with a texture and animated object, and the vertex animation is stored in a 3D texture. I want to close this tutorial by showing a promo and advanced example I shared with my Patreons. Maybe you also want to become one of those. And this one. So this is a complete scene with instances. They are all animated from one 3D texture, and the scene looks gorgeous because I used a lot of trickery, and we have a really powerful post-production that is made from things you can download. The video it's in the video description. It's a bloom from Navigator Design, and a component I made in order to handle tone mapping. The whole example is a baked 3D scene, their ER instances, as you can see. Please consider to subscribe, follow me on Patreon, and as always, happy programming to all of you. Ciao!